Our next presentation comes from another chair of a partnership, or past chair, Mr. Graham of Texas Department of Transportation. And Graham's going to talk to us today about UHPC practices and corroded steel repairs.
Very good to be here. Really appreciate Herb and Bill and the partnerships and inviting me along. A couple of us from Southeast Bridge, David Miller, just walked in. Working with this partnership really is one of the most enjoyable aspects of what I do, and I think the work we do as part of these meetings and what we learn and are able to take home, really pretty amazing. So very, very appreciative of the opportunity to be here. And I'll put a quick plug in on Jason's report. If you haven't read through that on the Approach Lab stuff, you really ought to. There is some great stuff in there. We are taking a fresh look at all of our Approach Lab standards based largely on the findings in that report. It is good stuff. So I'm here to talk about UHPC today, mostly one project, but I'll cover a second one. What is UHPC? There was a really excellent presentation on this morning, if you saw it from UHPC Solutions. So I'm not talking about what is UHPC, but here's just kind of a summary. I think probably most of you know that it's really strong, it's really durable, and it's stiff but ductile. So that's all I got for what is UHPC. Really wanted to talk about how we finally got around to implementing this in Texas. It's been on our radar for a long time. I mean, for years we've been looking at it and studying it, and there's very good work going on at FHWA with Ben and Zach and others up there, universities, lots of people looking at this. And we thought about it and we did some of our own research, and then we thought about it some more and actually specified it on a couple of projects, and contractors asked us to reconsider, and we just kind of laid down and said, we don't need UHPC. So we let them pretty easily talk us out of it, attended some more workshops and thought about it some more, but never implemented. And you've seen this map probably. UHPC Solutions showed the same map this morning. This is showing where all the UHPC is being used around the country. And you see a lot of blank spots on the map, and Texas is definitely one of them. That dot that looks like it's in Texas is in New Mexico, so we can't claim any on the current map. Unfortunately, opportunity presented itself. This happened in 2019. This is the Sydney-Sherman Bridge. This is Interstate 610, which is the main loop around Houston, over the Houston Ship Channel. So this is a major traffic route for trucks, for vehicles, for the ships underneath, really major roadway. It's fracture critical. You can see that it's got 6 girders, but the spacing is nearly 30 feet. So even though it's a multi-girder bridge, this is most definitely something that we call fracture critical. Found some very severe distress. Some corrosion product got cleared from these beam ends and found some pretty gnarly stuff. And it was found during a routine safety inspection, not during a fracture critical inspection. Anybody that attended the 2019 Southeast Bridge meeting in Baton Rouge heard me give a presentation on that, because that was most definitely something that we recognized as a breakdown in our inspection process. And so we've made some changes since then, but that was definitely, it wasn't a good time for this to happen. And you look at these photos and it's kind of hard to tell just how severe it is, but those on the right, you can kind of get an idea of what kind of problem we were dealing with. But in particular, that photo on the bottom right, it's hard to see what's going on there. And this was a Saturday, and I was looking at that photo on my mobile phone, trying to make sense of it. I turned it sideways and turned it upside down, and I couldn't figure out what it was. And I said, surely that's not a fracture in the bottom flange of this fracture critical girder. And that is a complete fracture of the bottom flange of the fracture critical girder. That's not a good thing, obviously. So this was a rough Saturday for a lot of people. So we didn't have to close it completely, but we did close a majority of the bridge. We were able to slide traffic over to some of the girders that didn't have nearly as bad a corrosion. But this is not the kind of thing you want to see on one of your fracture critical members on an interstate near downtown Houston. It wasn't just that. We had other problems. So you can see, I think a lot of us have had bearings move around on us and stuff. Here's one where we had the bearing plate move around on us, just about slid out right out from underneath that rocker. We also had some pretty nasty corrosion going on in the anchor bolts, and this is a bad day. I mentioned it was a bad Saturday to find all this. You can see we've got issues here. We do a temporary repair. This is not a bridge that we could leave closed or even have partially closed. So we got in there very quickly, and it's kind of a cool photo back and forth. So you see that photo on the right. Here's a photo from the same perspective, jammed in some extra steel welded it in place just to kind of hold things together while we could think about a permanent repair. Got some shim plates installed, welded a few extra stiffeners in, and this was a good quick solution that made us comfortable enough to get the bridge reopened. But really, we got to think about permanent repairs quickly. And so that's got to include resetting the displaced rocker bearings and addressing all these corroded members elsewhere. And so, the subject of the presentation was encasing girder end. It really wasn't just the girder end. In fact, a lot of the corrosion wasn't in the girder itself. It was in these bearing elements, and it's almost like a truss. There's just lots of convenient locations for water and other crapola to collect. And that's what led to the deterioration. So it looks obvious here. Part of the problem was we hadn't taken the time to remove all this corrosion product. So you couldn't really see how big an issue we had until somebody took that wire brush and took the time to clean this stuff up. So, all right, we got to talk permanent repair here. What do we do? Since a big part of this is going to be jacking the girders up, can we do it from the ground? Not really. This is a pretty high bridge. It's 110 feet. High, and you can see the rail right underneath. So lots of issues with that. We're also worried about the weakened girder webs. We didn't feel great about jacking the girders themselves. What about the diaphragms? Every once in a while, we will jack the diaphragms to lift the girder up. It usually works. We didn't feel great about that here either, because the diaphragms aren't all that beefy, and also they're weakened as well due to the corrosion. So we determined that the jacking has got to be done after strengthening. So what do we do? First thing that came to mind was just, lopping off the ends of those girders and welding in a new piece. And the photo there is from a project where they did that in Connecticut. Some drawbacks to that. It's going to necessitate the cutting of numerous plates and other members. Like I said, this wasn't just a girder issue. Lots of little pieces of the puzzle that needed to be addressed. So it wouldn't just be a matter of lopping off that girder end and putting in a new piece. Lots of stuff to do over there. It would take prolonged and widespread lane closure because we've got weakened members that we would be weakening further as we took pieces of steel out. So we would not have been comfortable leaving these lanes open. And like I said, the new joints are geometrically complex. We really wanted to try to eliminate these areas for water and the other muck to collect. While this was happening, we had another UHP workshop. We hosted it in Austin. Ben and Zach came down, and really good workshop. If you haven't been in it, I suggest that you find one to do. Really great info. And fortunately for us, a few of our Houston district engineers came. Houston is gigantic. We're TxDOT, but we do call it the Houston. We call it HUDOT. They're basically a DOT to themselves, so they got a lot of in-house capacity to do things themselves. And really one thing in particular caught the attention of the engineer of record for the Sydney-Sherman Bridge, and that is another example from Connecticut. And they had, instead of taking out the end of the girder and welding in a replacement section, they encased it in UHPC. So this seems pretty intriguing. And we were going to need something quite a bit larger than what they did in Connecticut, but really thought of this as a pretty good potential solution. And I talked about the need to lift the girders. This was really looking like it could offer a way for us to do that too. So in addition to encasing the corroded areas, it would allow us to beef up the diaphragms to the point that we felt like we could lift from those. Just some advantages of this concept. Really, I already mentioned, we would avoid the need for all that cutting and welding and other stuff we'd have to do, minimizing bridge closure time, which is a big deal in this location. No shoring towers needed, keeps us away from the railroad. Very important third bullet there. Creates a solid load path to transfer the load from the girders to the bearings, and also strengthens the diaphragms to enable jacking. Seals the girder ends, so this hopefully prevents a similar problem in the future because we're not going to be collecting that water and other stuff. That's it. So that's what we did. And I say we, TxDOT, so I'll help take credit, but I had nothing to do with this decision. I had nothing to do with this design. I was actually really proud of the Houston district engineer for doing this. I think it was a really super bold move and just a phenomenal design, and really awesome job. Pretty obvious steps. Step one, we got to weld in some steel plates and shear studs. I didn't include it in the presentation. That he's a great engineer. He came up with great details here. He actually did a finite element model on to determine the plates and the studs needed and all that. It's a little further than I probably would have gone. I think I probably would have just done some UHPC over some reinforcement and studs and called it a day. But he's a good engineer. He did the calculations and the numbers, and the FEM showed that everything was great. Then we got to place the UHPC, and then we jack the girders up and fix the bearings. So just a few quick details. The contractor utilized Lafarge. I think everybody's probably familiar. That's they're the ones that have been around a long time and have done a lot of the UHPC work around the country. Just a few details on dates there. Construction started in February 2020 and completed in September. That doesn't sound super quick, and it's not super quick, but a lot of this was really designed around not having to close the bridge. So there was a lot of preparatory work and a lot of kind of thought and stuff on the ground happening in order to allow us to minimize the time closed. And you can see there we had very, very, very limited traffic closures. We closed half the bridge once to encase 3 of the girders. We closed the other half once to encase the other 3, and then we did a full closure for 1 weekend so we could raise all 6 girders at the same time. But that was really the only impact to traffic, and that was a big deal in this location. So there's us getting started. We did a platform so we could get to this thing from the ground. It's possible to get to it from the roadway, but you really don't want to be doing that. So we got the stairs in, did some sandblasting and some lead abatement, and then we really get down to business. So you can see the steel plate being attached to the bottom of the diaphragm, and then lots of studs and a reinforcing cage. This was a big step, and the UHPC guys talked about this morning. Really, really important to get this mock-up done. We did not want to learn any hard lessons up in the air, and so we put together a full-size mock-up, forms around it, and really good thing that we did, because we all know, you hear over and over again that the UHPC is highly flowable. I think until you really get your hands on it, you don't realize just how flowable it is. So this is not a usual form setup, and we had a major leak happen. So thank goodness this happened on the ground during a mock-up and not in the air during a traffic closure that would have been extended with this happening. So really glad we did the mock-up. Forming, testing, reforming. Now we're up in the air. This is pretty difficult working conditions. Limited space up there. Not a whole lot of support locations to attach this stuff, and we also required that the contractor do a water test. So we had checked for it to be tight on the ground, but we wanted to make sure these things were tight in the air, and not all of them passed the test. So again, good thing that we tested it before we got the UHPC going. Nothing major, but they did have to rework some of the forms. Everything passed the water test the second time. Good to go. Now we're ready to place it. We did it on 2 occasions, like I said, 3 on 1 weekend, and then another 3 a few months later. Did it through funnels and PVC pipes, and Lafarge representative was on site to help oversee the work, and really just can't emphasize enough the importance of when you're trying something new, and we've learned this lesson the hard way on some other materials and things. You got to get the people there that know what they're doing. If this is new to you, as much as you might think you have it in the bag and it's going to go well, things are going to go wrong. So really, really important to have these manufacturer reps. And so we're really grateful to have had Lafarge personally there on site to help oversee the operations. We were down, obviously, under the deck watching as the stuff was getting placed, and went very smooth. A couple of minor leaks, but nothing that we couldn't deal with there on the spot. So I think this is where all the preparatory work really paid off. The mock-up and the water leakage test and everything else allowed things to go very, very smoothly once we got down to production work. Here's what it looks like, and that's what we wanted it to look like. The UHPC filled all the voids, really looked great. And then you can see, really most important, we've got that very now robust load path for the jacking operations. And so that's what we did. You can see the jacks there in place. We lifted those girders up. You can see that rocked bearing right there. We got the come along to pull it back into place. Got those corroded plates and everything else moved out, and new ones put in there, and there you go. There's a finished product. So very, very happy with how this turned out. Good. Tom Fans, the guy. He our engineer in the Houston district. He's not a supervisor. He's very experienced, but this is a staff engineer that had the guts to, see something in a workshop and say this is going to work. And this was our first UHPC in the state. So really, really very bold, outstanding engineering from Tom. So something he should be very, very proud of. He tries to deflect give him all these accolades and everything, and he just can't handle it. He really squirms and gets uncomfortable. But this was really him. Implementation number 2. Now this is not maybe necessarily a preservation project. Herb and I were debating this yesterday. Is a bridge replacement really bridge preservation? And I'll say it is. These are rural. This is a very rural location. The point I'm trying to make is if we can do UHPC here, we can do it anywhere. Anybody familiar with that region of Texas, it is the middle of nowhere. I mean, there is nothing there for miles and miles and miles. And so the idea that in Dallas and some of these other places, contractors talked us out of doing UHPC, don't let the contractors talk you out of it. You can get the UHPC if you really want it. So what we had out here was 5 bridge replacements in very rural areas. These are landlocked bridges. So we had to get them replaced, and we had to get them replaced very, very quickly. So we limited it to 10 days. So I'll call that bridge preservation. I don't know. Dick's over there saying it's a stretch, maybe. But, really, I'm talking about UHPC, not bridge preservation. So here's what the contractor came up with. We had developed a design that was some traditional bulb tees and full-depth deck panels. We're really kind of surprised when the contractor came to us and asked if they could use next beams. We don't really do very many next beams or any double tees in Texas, but we got no problem with them. We know they work well in other states, so we said sure. The original design did call for UHPC closures, and the contractor kept that in there. Here's what it looked like. Really pretty basic. There's your closure. We had some staggered bars in there, and one of the most remarkable things I think about UHPC is that you can fully develop a number 5 or a number 6 bar in just a few inches. So really amazing what this stuff can do. The subcontractor, UHPC subcontractor, submitted very, very detailed plan on how they were going to do this. So we had our plans, but they were very good about submitting very detailed plans because, again, this isn't something that you want to go wrong. One of the things that UHPC Solutions talked about in their presentation this morning was this is not material that you want to waste. It's very, very, very expensive. So you want to plan ahead. You want to get this right. You want to have all your ducks in a row before you get down to production work. And they were very, very good on this project about making sure that we did have everything ready to go. So there, you can see the closure there right before we were ready to get the UHPC in place. I talked about the mock-up on the Houston project. We really emphasized the importance of a trial batch on this project. So like the mock-up in Houston, really the extensive trial batching that we did, I think helped ensure that everybody kind of knew what they were doing. We had practiced it. We had gotten it all together. We had tested it. And it really got everybody ready for game day. High shear mixer. I think this is pretty normal operations for UHPC. It's not a normal mixing operation. You really need this high shear stuff, and you got to mix it for a lot longer than regular concrete. And it's not regular concrete. There's cement in there, but other than that, it's really very, very different than our usual concrete mixes. There's what it looks like. You can see just how flowable that is. Talked about the leaks that we had in the Houston mock-up, and that gives you an idea there just how flowable this stuff really is. Lots of the high-range water-reducing admixture in there to make that happen, and it's essential because you need this stuff to fill the voids. UHPC Solutions, again, they're the ones that did the work for us here, and they mentioned it in the presentation this morning. They are not suppliers. They are contractors. So SmartUp supplied the UHPC on this project, and UHPC Solutions mixed it and placed it. Went very, very well. We had Weber Construction as the prime, and they all three worked very well together, worked very well with us, and this is a cool project. Here again, like Houston, involvement from the experienced suppliers and contractors was just absolutely critical to the success, and so they were out there on site as well, so really, really important that happened. So there's the bottom side. You can see how it's formed up. The detail that I showed a couple slides back, it looks exactly like that, and they are placing it. Project is ongoing. Biggest hiccup has been the need to grind that surface, and there was more camber in the girders than we expected, but we knew about the camber, and the contractor knew about the camber, and they just kind of proceeded anyway. And they're learning the hard way that they shouldn't have done that. They've already locked up their equipment once trying to grind this UHPC. Once that stuff sets up, it's tough to grind out. It's not like grinding a usual bridge deck. So this is something that we really should have paid a little more attention to because the contractor's kind of in a bind now. I mean, they're going to get it done, but it is no fun trying to grind that UHPC. They're having to get it down a full inch in some areas. You can imagine, those of you familiar with UHPC, what that's been like. Overall, though, this is a highly successful project. Minus that camber issue and the grinding, things went very smoothly out here. There you go. They're kind of finishing things up, and doesn't look all that pretty, but it'll do. Had to move quickly. This is a successful project, and I think a good use of the UHPC again. And like I said, this is about as remote as it gets. So if we can do a successful UHPC project here, we really feel like we can do it anywhere. Coming projects. So we talked about the encasement of the corroded steel in Houston. We're actually looking at it at two of these super cool historic bridges, these variable depth T-beam bridges. We've got quite a few of those in the state. They're in great shape. These things are bomb-proof. I mean, they just really have held up well over the years, except at the ends. And so, that doesn't look great, right? This is something we've got to address. So outside of this, the bridges are in really good shape. So we thought about what we wanted to do here, and we're going to encase it in UHPC. We see no reason that it's not going to work here just as well as it would with the steel. Very robust, strong bridges, so we're really not concerned at all about the UHPC encasement and the transfer of load and really extending the life indefinitely of these bridges with the encasement. These are my closing thoughts. My last slide. There's the map again. That's not official, but I added our 4 spots in there. So the one in Houston is done. The one on the top there is done. The 2 in the middle are one's in Waco, one is in San Angelo. Those are the historic bridges that we're going to encase the beam in. So I'll have to make sure that Zach updates the map to reflect our 4 projects. But really, what I wanted to say was, as engineers, and I give a whole presentation at our Hot Springs meeting a couple weeks ago, really not to overthink it, and talked about Tom Phan's willingness and being bold enough to get out there and do it. At some point, got to pull the trigger. I think we as structural engineers can overthink some of this technology. At some point, we just got to pull the trigger. Be willing to stick to it if you feel like new technology is worth implementing. Don't let contractors talk you out of this stuff. Listen to the contractor feedback. It's important that we do so, but we were a little too eager to let them talk us out of it on the first couple projects where we specified it. Make sure you get experienced people involved. That goes for UHPC or any other new material that you're implementing. And really just can't emphasize enough how important it was that we had those trial batches and mock-ups in place. It really made the production work itself go very smoothly. We learned our hard lessons during the trial batches and the mock-ups. Production work went very well. Bill, that's all I got. No, there was more work done than what was shown in the photos. We got a lot of shims, we got a lot of temporary supports put in place. So we just sort of did what we needed to do to safely get the bridge open. It's not something that we would have relied on for a long term, but on a short term basis, we felt like the shims restored sufficient bearing, getting those bearing plates, the temporary pieces put in. So it wasn't pretty, but it worked. Oh, I'm sorry. Did you mean, okay, no, that came out. Those pieces came out. So when we jacked up from the encased UHPC, we pulled all that stuff out there. So there was the one photo I showed that really the only thing left was the rocker itself. Everything else underneath had been removed. Correct, yes. Okay, now I see what you're saying. Yes, we cleared out all the corroded steel that was outside the encased area. I don't know. Beyond not engineering it, I unfortunately was not even on site while they did it. There's access from the bridge deck to get down there, so I don't think they had to cut any holes in the bridge deck. I'm not actually sure what they put the PVC through. Yeah, so they did. They installed some PVC pipe and just ran it down that way.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.